Hello everyone, welcome to Manyam Java Central. Myself Manyam Prasad. In the last session, we have discussed about functional interfaces and lambda expressions in a high level. Last session was a part of functional interfaces and lambda expressions. In that session, we have discussed the syntax of lambda expressions. And we also discussed the concept of why, how and where. Means why lambda expressions and how to implement lambda expressions and where to use lambda expressions. And even we have discussed the examples on lambda expressions. And not only lambda expressions, we have also discussed the concept of functional interfaces. The same principle we have followed for functional interfaces also, which is why, how and where. That is, we have discussed why functional interfaces, how to implement functional interfaces and where to implement the functional interfaces. If you didn't watch that session, I will leave that link in the description. You can watch it. Now, this session is all about functional interfaces and lambda expressions as a part 2. In this session, we are going to discuss how to use lambda expressions to create a thread, anonymous inner classes versus lambda expressions, functional interfaces in inheritance, how to use lambda expressions in a collections, predefined functional interfaces and its types. So these are all the things we are going to discuss in this session as a part 2. As part of this session, we are going to discuss about lambda expressions and functional interfaces as a part 2. We already completed part 1 of lambda expressions and functional interfaces. As part of session 1, the first and foremost is how to use lambda expressions to create a thread via runnable. Before going to discuss about creation of thread using lambda expression, first we have to know how to create a thread without using lambda expressions. That is, we are going to know how to create a thread using classic approach. Means how to create a thread using normal and regular Java. Let's proceed our discussion with a small code snippet. See, to create a thread, first of all, you have to take a user-defined class, which will be implementing from a runnable interface. Let's take a class. Take user-defined class, myThread implements runnable. And we need to override run method in order to write our thread logic. Public void run. So as part of my thread logic, I need to print a small statement 5 number of times. Let's print that statement. For int I is equal to 0, I less than 5, I plus plus. Sysout task 1, Manyam Java Central. And next one is create an object for user-defined thread class. myThread empty or myThread is equal to new myThread. And next you have to supply myThread reference to thread class constructor. Thread is equal to new thread, and you have to provide a reference of myThread. In order to execute the run method, you have to use start method of thread class. Thread.start. That's it. This is all about creation of thread using normal and regular Java approach. Let's execute this application and see the result. So see, this is the output. So it is printing Manyam Java Central 5 number of times. This is the thread logic. So if you observe the above code, so did you observe any disadvantage in the above code? Yes, absolutely. We have a disadvantage. So here for creation of thread, I have taken myThread as a user-defined class, and it is implemented from a runnable interface. And also we have overridden a run method for providing our thread logic. Taking user-defined class and implementing from runnable interface and overriding run method is useless. So instead of this implementation class and all the stuff we have written, so just we have to use anonymous inner class in anonymous inner class and provide that anonymous inner class as a thread class constructor. So that's enough to creation of thread. If you observe carefully in line number 13, for a thread class constructor, we have passed the reference of user-defined thread class. And our user-defined thread class has implemented separately. And this implementation class is used only once for creating a thread. Instead of doing all these things, we can do an alternative, which is nothing but taking anonymous inner class. Now, in place of my thread, directly we can provide the anonymous class of a runnable interface and override the run method without thread logic. That's it. Let's quickly replace the above code with anonymous inner class. So now I don't need all those things. Just to create thread class object, thread is equal to new thread. And here you need to provide anonymous inner class to runnable interface and override run method to provide your thread logic. That's it. So create anonymous inner class, new runnable. Here override thread logic, override run method to provide a thread logic. Public void run for int I is equal to 0, I less than 5, I plus plus. Sysout task 1 Manyam Java Central. You have to call this using start method. Thread dot start. That's it. Let's execute this above code snippet. So see, we are getting the same output what we got using previous program. Now we will see how to use lambda expression to create a thread via runnable. So for creating a thread, just now we have used anonymous inner class. Instead of using anonymous inner class, let's create a thread using lambda expression. We know already if we see any anonymous inner class logic, let's replace that anonymous inner class logic with lambda expression logic. We understood that a runnable is a functional interface, and that runnable functional interface contains only one abstract method, that is a run method. So wherever functional interface is there, we can write lambda expression. So let's see the code. In the below program, we can create a thread by implementing the runnable interface using lambda expression. While using the lambda expression, we can skip the new runnable and run method because the compiler knows the thread object takes a runnable object and that contains only one method, run, that takes no argument. So if you see, I have provided lambda expression implementation, and that implementation I supplied to thread class constructor. If you see here, run method of runnable functional interface does not contains any parameter. That's why I have taken empty braces and arrow operator, and I have opened the curly braces in order to provide my thread logic. And this entire lambda expression logic I supplied to thread class constructor. And at last I have used start method to execute the run method, which was implemented with lambda expression. Let's create a thread using lambda expression in IDE. Now you see already this is a code for anonymous inner class. So in place of anonymous inner class code, I can write lambda expression code. Let's remove it and we can provide lambda expression code. So see, now we can provide implementation to run abstract method in the form of lambda expression. You know already run method does not contains any parameter. That's why we need to take empty brace, arrow operator, and use curly braces in order to provide thread logic. For int I is equal to 0, I less than 5, I plus plus. Sys out task 1, Manyam Java Central. That's it. So this is all creating a thread using lambda expression. Let's execute this code. So the same output we got. So this is all about creation of thread using lambda expression. And next one is anonymous inner classes versus lambda expression. As we know that Java 8 has come up with a lot of new features. Lambda expression is one of them. But before Java 8, we are having anonymous inner classes. Now we will see how lambda expression is different from anonymous inner class. So what is anonymous inner class? Anonymous class is an inner class without a name. We can declare and instantiate that class at the same time, and for which we can create a single object only. So basically, anonymous inner class avoids the creation of subclass just for the sake of overriding a method. So we can understand these two sentences with a small snippet of codes. Suppose you have an interface vehicle. Let's say I have a vehicle interface, and this vehicle interface contains a method blow horn. This method is taking sound as a parameter. So let's take one more implementation class to implement the vehicle interface and provide implementation for blow horn method. See, I have a car implementation class which provides implementation to vehicle. If I am providing implementation to vehicle interface, I must and should override blow horn method to provide implementation. So I have overridden the blow horn method and I have provided implementation. So in order to use this functionality of car, I have to create an object for car. So let's see how to create an object for a car. Vehicle car is equal to new car. So did you observe the drawback of above code? Yes, I have a drawback. So what is the drawback? Just for the sake of overriding the blow horn method of the interface, I have written the car class. Just for the sake of overriding the blow horn method, I have written the car class. Apart from that, nothing will be there to write the car class. So say I don't have any advantage of writing the car class. Just only one thing is there. So I need to override blow horn method. For this, I have written the car class. So I don't create a subclass just for the sake of overriding the method. And moreover, I need this class to be executed and instantiated at the same time. See, where can I use the car class? So in the main method class only, I need to use the car class. But at the time of loading that main method, I need to execute this car class. Both at a time need to be executed. My main method class will be executed at the same time, and the car class will also be executed at the same time. So for this, instead of creating the different class and overriding the method of implementation class is useless. So replace the above code with anonymous inner class. See, I have, so frankly speaking, I no need to write car class. So why should I have written the car class? Just for doing implementation to blow horn method. Because of only this purpose, I have written the car class. So instead of writing car class just for overriding the blow horn method is useless. Instead of writing a separate car class, we have to take anonymous inner class concept in a test class. So replace the above code with anonymous inner class. Just see here. See, instead of writing the separate implementation class in the main method itself, so I have written the anonymous inner class, means nameless class. So see, vehicle car is equal to new vehicle. Under this, I have overridden the blow horn method to provide my own implementation and call that method by using the anonymous inner class reference. That's it. You no need to write any separate class for overriding that method. And the main advantage of writing this anonymous inner class is at the time of executing this test class, this vehicle functionality is also executed at the same time. That is the main advantage. So see, as you can see, the anonymous inner class is the self-explanatory. The anonymous inner class is self-explanatory. It is an inner class because it is a class within a class. It is anonymous because it has no name. Use an anonymous class when you want to use local class. This is a separate class. Let's write this anonymous class in a IDE and see the result, what will happen. First, to see the anonymous inner class, first we can write a code without taking anonymous inner class. And next, we will convert that normal code into anonymous inner class. I have an interface, vehicle. In this vehicle, I have an abstract method, public string blow horn, string sound. So in order to override this blow horn method, I have taken one implementation class. Class car implements vehicle. And we have to override public void blow public string blow horn string sound. Return car plus sound. So in the main class, we have to create an object. Vehicle car is equal to new car. Car dot blow horn. So how the horn of car will be? Boom. This is a sound. Okay, let's execute this code. So you have to place this system.out.println car dot blow horn. Let's execute this. So car boom is the horn. So already we have discussed that instead of writing the implementation class unnecessarily, so we have to replace this implementation class with anonymous inner class. We no need to provide implementation class separately. So how to provide anonymous inner class? Vehicle car is equal to new vehicle, and under this we need to override abstract method, public string blow horn, string sound, return car plus sound. So how to call that method? By using sysout car dot blow horn. So your horn will be boom. Let's execute this. See, the output is boom. Okay, so this is all about writing the anonymous inner class instead of creating the separate implementation class for overriding the method of interface. And we have to learn one more anonymous inner class. Let's take an interface, test interface. This test interface is having two abstract methods. So instead of writing an implementation class and overriding these two methods, taking separate implementation class, and instead of overriding the above two methods, so we need to write anonymous inner class in the test class itself. So let's see here. I have taken anonymous class test. I have taken test class and I have written the main method. In the main method, I have written anonymous inner class of this test interface. And in this anonymous inner class, I have provided implementation to two methods, display and extra method. And you have to call these two methods by using the reference variable of anonymous inner class. So let's quickly implement this code in a IDE. So this is an interface test interface. In this, I have two methods, void display and void extra. So any method you can take. So here, instead of taking a separate implementation class and instead of overriding these two methods in that implementation class, I have taken an anonymous inner class in the test class. So see here how to write anonymous inner class. Test interface test is equal to new test interface. And here you need to provide implementation for these two methods. Sysout, another abstract method implementation, and just to provide implementation to this method also. Sysout my anonymous class implementation for test interface. That's it. So how to call these two methods? By using the reference of anonymous inner class. Test dot display, test dot extra. That's it. Let's execute these two classes. Let's execute this functionality. See, I am getting the output for two methods. That's it. Let's say we have other examples of anonymous inner class. So see, thread T is equal to new thread. So for this thread, we have provided implementation. And runnable R is equal to new runnable. You know, new runnable and provide implementation here. So these two are also another examples for anonymous inner class. So you know already wherever we have anonymous inner class, so it's better to replace that code with functional interface. So see, wherever anonymous inner class is there, we can use the functional interface. It's better. So Lambda expression can implement an interface containing single abstract method, that is functional interface. See, if you observe any code, any anonymous code, then you have to replace that anonymous code with a Lambda expression code. Means it's better to write functional interface there. And while replacing that code as a Lambda expression or functional interface, you must and should remember one thing. If that anonymous inner class has only one abstract method, then you can convert that anonymous class as a functional interface. So otherwise, we can't, because functional interface has only one abstract method. Okay. Next, see here, I have a functional interface drawable. And this drawable functional interface contains draw abstract method. So how to provide implementation to this one? So drawable D is equal to open brace, arrow operator, and you have to provide implementation. and you have to call this method by using the reference variable of functional interface and call that method. That's it. Interface drawable. So I have a method, abstract method, public void draw. And in order to designate this drawable as a functional interface, it's better to write at the rate functional interface annotation, at the rate functional interface annotation. And how to provide implementation to this functional interface method using lambda expression. Drawable reference is equal to and provide lambda expression implementation to the method of drawable interface and assign that lambda expression implementation to reference variable of drawable functional interface. Open close brace, arrow operator, and you have to provide implementation. Sysout draw the logo for Manyam Java Central. That's it. And wherever you need this, you have to call that reference dot draw. That's it. Let's execute this. So draw the logo of Manyam Java Central. Next one is functional interface with respect to inheritance. Now the time came for quiz. Case 1. See this code snippet, and you have to observe this code snippet is valid case or invalid case. I have an interface, functional interface A, which contains one method M1, and I have a functional interface B, which is extends A. And is this a valid case or not? Absolutely, this is a valid case. If functional interface B is extending from A, this M1 is overridden in interface B. Now functional interface B contains M1 abstract method, so which is a valid. See, this is a valid, and I will provide the explanation for this. M1 method got inherited into interface B. After the inheritance also, the interface B is having only one abstract method. So in this case, interface B is functional interface. Next one is, so see whether this case 2 is valid functionality or not. So I have an interface A, functional interface A, which is having M1 method. And I have functional interface B, which is extending A. And moreover, if you observe, functional interface B is having M1 method. If I extending A to B, this M1 method is overridden into interface B. And both the M1 are same, right? That's why interface B is having only one abstract method M1, which is valid. So see, this is valid because we are overriding B's M1 with A's M1. So ultimately, functional interface B is having only one abstract method, which is valid functional interface. Let's see case 3. So tell me whether this case 3 is valid functionality or not. So I have a functional interface A, which contains M1 method, and I have a functional interface B, which contains M2 method. If I extending B from A, B contains method M1 from A. Ultimately, functional interface B is having how many methods? 2 abstract method, which is not a functional interface, but we are taking here at the rate functional interface. If any interface is designated with at the rate functional interface, then that functional interface is having only one abstract method. But here in this case, we have 2 abstract methods, which is invalid. So this case is invalid because child interface is having 2 abstract method, which is invalid. Next, case 4. I have a functional interface A and contains M1 abstract method, and I have functional interface B, which is extends from A. I have a functional interface A, which is having M1 method. I have a normal interface B, which is extends from A. So in this case, this is valid. B is not a functional interface, right? So that's why B is having more than one abstract method, which is valid. Yes, valid. So in the above case, here parent is functional interface and child is not a functional interface. It's a normal interface. So if an interface is having only one abstract method, it is always functional interface. Otherwise, it is not a functional interface. So next concept is using lambda expression to sort the collections. Now we are going to see how to use lambda expressions for the collections. So let's see the below example. I have a number list, means some values in the array list, integer values in the array list, 5, 4, 0, 100 and 1 lakh. Now I need to sort the values which are available in the array list. For this, I need to use sort method of collections utility class. For this sort method, I need to provide two parameters. One is array list reference and another one is comparator implementation class. So if I execute this, my control will goes to sort method of collections and it has to go to the implementation class of my comparator interface. There it will execute the code. Actually, comparator interface contains compare method. So see the code snippet, what is available in the comparator interface. So the method collections.sort is taking two parameters. One is array list reference and another one is comparator. So comparator contains only one method, that is the compare, which is taking two objects. And this compare method is returns integer value. Now for every time we sort, it is going to call compare method and returning negative value or positive value or zero value, depending on comparison of the two objects. See, if the compare method returns the negative value, then we can understand that obj1 comes before obj2. And if the same compare method returns the positive value, we can understand that obj1 is coming after the obj2. If the same compare method returns the 0, if obj1 and obj2 are equal. So based on the values returned by the compare method, it is sorting all the objects which are present in the array list. Let's see the code snippet here. So this is the implementation class of comparator. And we are overriding the compare method. And in this compare method, it is taking two objects, means two values at a time of array list object. So if object 1 is less than object 2, it is returning -1. If this obj1 is greater than obj2, it is returning +1. If both are equal, it is returning the 0. This implementation, and let's execute that code snippet to see what will happen. List, I am taking integer values, number list is equal to new array list. So number list dot add 5, number list dot add 4, number list dot add 0, number list dot add -100, number list dot add 1 lakh. So now I need to sort all the values present in this array list. For this, I have to use what? Collections dot sort number list and use comparator implementation class object new my comparator. Let's print all the values. Sys out number list. Class to comparator. Class my comparator implements comparator. It will take integer. Let's override compare method. Integer obj1, integer obj2, and you already know how to provide implementation to sort. If obj1 less than obj2, return -1. If obj1 greater than obj2, return 1, else return 0. Else return 0. That's it. So let's execute the above code. So see, we are getting an output with sorted list. And next one is, if you observe the above code, if you observe this code, I have written implementation class to comparator interface. And you know already in Java 8, comparator is a functional interface. It is having an abstract method, compare method. So instead of writing implementation class to comparator, and instead of overriding compare method, let's remove this implementation class and provide implementation to compare method of apps using lambda expression. So let's remove this implementation class, and in place of new my comparator, we have to write lambda expression implementation to comparator interface of compare method. So you know compare method is taking two parameters. Those are obj1, obj2, and write the arrow operator and provide implementation here. If obj1 less than obj2, so what will happen? Return -1. If obj1 greater than obj2, return 1, else return 0. Return 0. And here, wherever you need, you have to call. See the output of this one. So we are getting sorted list. So see this, see the explanation. As we discussed right now, I have a number list. This number list is taking some integer values, and I am calling the sort method of collections utility class, and the sort method is taking two parameters. One is array list, and another one is implement lambda expression implementation to abstract method of compare method in functional interface. So which functional interface? Comparator functional interface. That's it. So let's see another example to sort tree set using lambda expression. Set integer tree set numbers is equal to new tree set, and this tree set constructor will take lambda expression implementation to comparator interface. So let's provide lambda expression implementation to comparator interface. So compare method of comparator interface is taking two parameters. Those are obj1, obj2. If obj1 greater than obj2, then we have to return +1. Else obj1 less than obj2, we have to return what? -1. Else we have to return 0. We have to return 0. Let's provide some values to tree set. Tree set numbers dot add -1, tree set numbers dot add -100, tree set numbers dot add 20, tree set numbers dot add 15, tree set numbers dot add -1000. Sys out elements after sorting are plus tree set numbers. Let's execute this application. See, we are getting sorting tree set values. This is all about a lambda expression for tree set sorting elements. So see this code. This is the code implementation for just now what we have done. Next one is lab exercise. See, sort the tree map using lambda expression. This I am leaving to you. You have to do as part of lab exercise. Next one is sort all employees based on their employee number. This I will do as part of this session. And next one is sort the data based on alphabetical order with respect to employee name. This I will leave to you. You have to do as part of your lab exercise. As part of this session, I will show you how to sort all the employees based on their employee number. So create employee class, new class, employee. So in this employee, we have to write string name int employee number. Let's create the constructor. Generate constructor. Let's create setters and getters. Actually, here no need of setters and getters. Let's create the toString method. Source generate toString. That's it. And next one is take the main class. In the main class, let's create array list in order to store all the employee objects. List employee emp list is equal to new array list. New array list. Next, emp list dot add new employee Prasad and his employee number is 101. Emp list dot add new employee Manyam and his employee number is 1. Emp list dot add new employee, his name is Pawan and his employee number is 1000. Emp list dot add new employee and his Kumar and his employee number is. Now I need to sort all those employees based on their employee number. That's why I need to use sort method of collections utility class. Collections dot sort emp list, and here I need to provide lambda expression implementation to comparator functional interface, and even dot e1 e2. So here e1 dot e number less than e2 dot e number, then we have to return -1. Return -1. Like that, if e1 dot e number greater than e2 dot e number, then return +1, else return 0. Sysout emp list. Let's execute this code snippet. Test. Okay. So see, we are getting first employee number 1, 70, 101, and 1000. So here we are sorting the employees based on their employee number. So here sorting the tree map based on lambda expression and sorting the data based on alphabetical order with respect to employee name, you have to do. I am leaving to you as part of the lab exercise. You have to do these exercises. Next. So what are predefined functional interfaces? So Java 8 has provided some predefined, means built-in functional interfaces to make our programming easier. Java provides a bunch of predefined functional interfaces that come under java.util.function package. So predefined functional interfaces include most commonly used methods which are available to programmer by default. So we can utilize the predefined functional interfaces instead of creating our own every time. They will obviously save our development time and minimize chances of mistakes. So by this, what we can understand is for each and every small requirement, programmer need not to do their own code. Instead of writing their own code, you have to use predefined functional interfaces provided by Java 8. For example, I need to do some functionality based on my program returning the Boolean value. If my program is returning the positive value, I have to execute some set of statements. If I want to execute some other set of statements based on the negative value returned by my program. So to return the negative value or positive value, I need to write some set of code. Instead of you writing that code, Java 8 has provided some predefined functional interfaces. Make use of that predefined functional interfaces, and based on the result returned by that predefined interfaces, you have to execute your set of codes. And not only that, based on the return value, you have to execute some set of codes. So in order to provide that return value, you have to write the code. Instead of you writing the code, Java 8 has provided some functional interfaces. Rather than you writing the code, just you have to make use of predefined functional interfaces provided by the Java 8. Now we are going to discuss what are the predefined functional interfaces provided by the Java and whether those are really helpful to the programmer. We are going to discuss those things. So see, why are predefined functional interfaces mandatory to learn? Yeah, so predefined functional interfaces are mandatory to learn because upcoming Java releases are most of the code depends upon the predefined functional interfaces only. So see, the Java community has started using predefined functional interfaces in new APIs. At least it becomes very crucial to have an idea of method parameters and return value of each method in your mind. If you are not familiar with them, it will be very difficult to understand even new APIs in the language, including JavaStream API. See, each and every predefined functional interfaces has its own characteristics. Some of major ones are predicate, consumer, supplier, function, and we will discuss one by one. First one is predicate. So we can use predicate to implement some conditional checks. So conditional checks in the sense predicate will provide Boolean value. So based on the Boolean value written by this predicate, we have to execute some set of statements. If it will return true, we will execute some set of statements. If predicate will return false, we will execute some set of statements. And next one is it accepts a single input and always returns a Boolean value as output. So we can provide a single input to the predicate. If after taking that input, predicate will returning the either true or false. If predicate will return the true, we have to execute some set of statements. If predicate will return the false, we have to execute some set of statements. So in order to provide input, predicate has one method called test. It supports a single abstract method named test. When you have this type of requirement to write a method, use it confidently. Predicate is the functional interface. It has a method test. Test is taking input. Here T represents type of the parameter. Let's see a small example. Suppose we have to write a program to check if a number is single digit number or not using lambda expression. Since this functionality depends upon the conditional check, we will implement that check using predicate. See this code snippet. This is the implementation of code using lambda expression. And obviously this lambda expression implementation is returning the true or false. That is assigned to predicate reference variable. So we can provide our input value to the test method which belongs to predicate. So let's see this code implementation in IDE. So I have predicate, it is taking integer as input, reference variable into predicate is equal to, you can write lambda, you can write the code implementation in the form of lambda expression. So I have I, it is taking the value in the form of I, and we will check this I greater than -10, and if the same I is less than 10, then we can say this is a single digit. So how, I mean, supply this value to test method into predicate dot test, you can supply any value. So this will assign this to Boolean value is equal to into predicate and print this value sysout value. Execute this. So 11 is a single digit value? No. So it is giving false. Let's write one more program. So in this example, what we can do is I will provide some string values to array list. If that string value length is equal to 3, I will remove that string from array list. And remaining string values, I will iterate and I will print all the values. So let's take here list string list is equal to new. Next one is string list dot add Goa, string list dot add orange, string list dot add red, string list dot add Hyderabad. And now I will take predicate, which is taking string predicate is equal to list any parameter list strings dot length equal to 3. So string list dot remove if string predicate sysout string list. So what I have done is, by using this lambda expression, I have checked the string length is 3 or not. If the string length is 3, what I am doing is I am removing those strings which length is 3. And for remaining, I am printing the string list. After removing the strings which is having the length 3, the remaining strings I am printing. That's it. See, Orange and Hyderabad are the strings whose length is more than 3. Next one is function. So here, unlike predicate, the function is used to perform some operation and return some result. So actually in the predicate, it is taking the value and it returns the Boolean value, either true or false. So here function is taking one parameter. So it takes 2 arguments, where first argument is to represent the input and second is for output. It is used to perform some operation. After doing that operation, it will give some result. So this predicate, unlike predicate, which returns only Boolean, function can return any type of value. It supports a single abstract method, which is apply. So it is not returning only one value. It will return different types. Let's see the signature of apply method. So I have a function interface which contains the apply method. R represents the return type and T represents the input value. See, I have a small example to find the length of the string using lambda expressions. Since it is taking an input string and performing some operation and it is returning the result. So we will implement the function as, see this code snippet. So S arrow operator S dot length is a lambda expression. So this implementation is to find out the length of the string. And this is assigning to function reference variable. That's it. Let's write the code in IDE and see the result. Function, it will take string as input and it will return the output in the form of integer. String value is equal to S arrow symbol S dot length. That's it. And sysout the length of string is plus string value dot apply, provide your string. Manyam Java Central. That's it. Let's execute this example. So the length of the string is 19 characters. Let's say one more example. This example is, I will provide one string and that string will convert it into uppercase. For this, I need to write a function, so which will take an input as a string and it will provide the output is also a string. Capital string is equal to S dot to uppercase. Sysout capital string dot apply mjc sysout capital string dot apply manyam java central. Let's see the output. See, the result will be in uppercase. Next one is consumer. See, this consumer is used when we have to provide some input parameter and perform certain operation, but don't need to return anything. So it is taking one input parameter and it will do some operation and it will not return any value. Moreover, we can use consumer to consume an object and perform certain operation. It supports a method except it does not have any return type. See the signature. So consumer is a functional interface and it is taking and it has accept method which is taking an input value. So let's see the example. We have to write a program to find length of the given string using lambda expression. Since it is taking an input, performing some operation, and it is not returning a result. So how can we write? So see here, this is a lambda expression implementation. It is taking a string and it is printing the string. That's it. Let's see this code snippet in IDE. Consumer, it is taking an input as a string. String value is equal to yes. Sysout, the string is yes. String value dot accept manyam java central. Let's see the output. So just it is printing the string manyam java central. That's it. And next one is supplier. Supplier does not take any input and it always returns some object. It accepts no arguments but returns a value. However, we can use it when we need to get some values based on some operation like supply random numbers, supply random OTPs, supply random passwords. In this case, actually, if I need to get any random number, or I need to print any OTPs, or I need to provide any password, so I don't need to provide any input. Rather, we are getting some output. If that is the case, confidently you can use supplier functional interface. So let's see the signature of supplier functional interface. So we have a supplier interface and it is having get method. Get method does not take any input parameters. Rather, it is returning some value. For example, suppose we have to write a program to display the date and time. For this, we will implement supplier as below. See here. So I have a lambda expression implementation. So just I am giving new date and I need to print this date object. So here supplier is not taking any parameter. Rather, it is giving date value. Supplier date is equal to new date. Date dot get. That's it. So it is giving date output. So the output is it is providing date, today's date. Let's take one more example. Variable static string name is equal to manyam java central. So in the main method, I will take supplier boolean bool supplier is equal to, it is not taking any value, name dot length equal to 10. Supplier integer int supplier is equal to name dot length minus 2. Supplier string supplier is equal to name dot to uppercase. Sysout bool supplier and next one is sysout int supplier sysout string supplier. Let's see the output. Out bool supplier dot get sysout int supplier dot get sysout string supplier dot get. Let's see the output. So first one is boolean supplier. Is this length Manyam Java Central is length equal to 10? No, the length of Manyam Java Central is not equal to 10. That's why we are getting false. And length minus 2 is a 17. And next one, I have converted this Manyam Java Central string as a uppercase. So these are all about predefined functional interfaces. And next, conclusion. So we learned about what functional interfaces are in Java with example. We discussed Java lambda expressions and functional interface annotation in Java, in which we covered java.util.function package. We also saw how lambda expressions are beneficial for efficient coding. Did you like our efforts? If yes, please like and subscribe to Manyam Java Central and share this video to your friends, those who are struggling to learn functional interfaces and lambda expressions. So thank you. Please subscribe, like and share. Please like Manyam Java Central on Facebook.